Okay, this is another recap starter, so pause the video and have a go at these questions here, please. Okay, hopefully you've had a go at them questions. I'm going to put two more up there for you to have a go at. So have a go at these two questions now, please, and pause the video. Okay, hopefully you've had a good go at them. I'm going to go through the questions now for you to check your answers. So when we say the word reciprocal, in non-mathsy words, it means 1 over. In mathsy words, it means to the power of -1, which we should know. If we had 3 to the power of -1, that would equal a third. So in this case, the reciprocal of 3 equals 1 over 3. The reciprocal of 1, well, 1 to the power of -1 is just 1 over 1. Or if we were looking at it in the non-mathsy words, we could say, well, 1 over 1 is just 1. The reciprocal of 1 is just itself. Very exciting, isn't it? Work out the probability that both traffic lights will be green. Well, first we need to complete our tree. These probabilities here must add to make 1, because the likelihood of something happening, it being red or not red, is going to be 100% chance of happening, which in probability we say is 1. So 0.8, 0.7, these here are the same event, so it's going to follow 0.3 and 0.7 again. Let me get a different colour for this. So work out the probability that both sets of traffic lights will be green. So it's either going to be, I assume this is either going to be red or green. There's no orange in these traffic lights in Swindon. So with it being not red, then that's going to be green. So green and green. When we go across our branches, we multiply our fractions or our decimals there. So 0.8 times 0.7, that is going to be 0.56. So the probability that the lights will be green, that both sets of traffic lights will be green, is 0.56, 56% if you want to say that. But the decimal is completely fine. Work out the probability that exactly one set of traffic lights will be green. Well, we could have 3 options here, both being green, green then red, or red then green. I don't want to be doing 3 calculations, so what I'm actually going to do in purple here, I'm going to figure out the probability of it being red twice and then subtract that from 1, because if it's not red twice, then it must be green once. So if I do the probability of red then red, that's going to be 0.2 times 0.3, so 0.06. So the probability of it being, oh sorry, I read the question wrong. Probability of it being green exactly once. So I will rub out all my lines here and I'll redraw the probabilities in. So 0.8, 0.7, 0.3, 0.7. Okay, so it being exactly once, it's either going to be green, red, or red, green. So we're going to have 0.2 times 0.7, which is 0.14, and then we're going to have 0.8 times 0.3, which is 0.24. We then add these at this stage, so that's 0.38, or 38% chance of it being green exactly once. The question I was doing before is at least once. A salesman sells 140 cars in 2009, he sells 189 cars in 2010. Work out the percentage increase. So percentage increase, we want to find the change and divide it by the original, and to turn it into a percent we multiply by 100, because a percent means out of 100. So the change is going to be 189 over 140, take away 140. The original is going to be 140, and we're going to multiply that by 100. So this might be a job for a calculator, so I'm going to type that in mine. So a quite nice 35% increase. You can always check that by increasing 140 by 35% and seeing if you get to 189, which you will do. 5 kilometers into kilometers per hour into meters per second. So I'm not the biggest fan of these unit conversion questions. I find them a bit confusing, but I have quite a nice method that I learned a month ago or so that I like. We want to change kilometers into meters, so we want a fraction that has kilometers on the bottom, because when we do this, we're going to be able to, just like we would with numbers, if we had 2 there and 2 there, we could cancel them out. So how can I write this fraction so it doesn't change the value but just changes my units? Well, we need this fraction to equal to 1. And the way we're going to do this is, well, if we take 1,000 meters and divide it by 1 kilometer, if we convert the kilometers into meters, that'd be 1,000 meters divided by 1,000 meters, which equals to 1. So if I write on the top here 1,000 meters, this fraction just equals to 1. It's just going to change my units and not change the value of anything. I also need to do this for hours. So if I have hours on the top, into seconds, well, in 1 hour, there are 60 minutes. And in a minute, there's 60 seconds. So if we do 60 times by 60, there's 3,600 seconds in there. So I can have this on here as well. What this fraction is going to equal is just again equal to 1. So it's not changing my numerical values, it's just changing my units. And then again, I can cancel out my hours with my hours. So we can see my only units left are meters and seconds. I just have some numbers to work with now. So if I rewrite out what I have on these fractions, so 5, and then I've got 1,000 meters, and I've got 3,000 seconds from here. So if I do that in my calculator, 5 times by 1,000 and then divided by 3,600, I'm going to get 1.38 meters per second.